Hi folks, welcome back to another edition of Quantitative Skills and Reasoning, and today we're going to be talking about the art of problem solving. So without further ado, we're going to just get started, get right into it, and we're going to talk about this cost conversion. So Giada is planning to make dinner for friends and family for the upcoming holiday. While at the grocery store, Giada notices that eggs are on sale if you purchase 30. The total cost of the 30 eggs is now $5.75. Meanwhile, a dozen eggs would cost Giada $2. Which is the better purchase in terms of price per egg? So say Giada could purchase 36 eggs or just 30 and she'd be able to use them all either way. So the way we do this is we have to go through a process, and the process begins with preparing. When we're preparing, there's a couple different approaches. You can start with what you're looking for, or you can just write down some of the given information. And just to kind of get in the swing of things, I'd suggest just writing down the given information and we'll try and work from there. So in this case, the given information is the cost of 30 eggs is $5.75, and you can see that from right in here. And in a similar manner, we have the cost of 12 eggs being $2. So that's given right in the problem. Now, where do we go from here? Well, we want to brainstorm, and the first thing, if we didn't put it in the preparation, we should brainstorm is what are we looking for? Okay, so what are we looking for here? Well, we're looking for the price per egg. And in this case, the cheaper that price, the better, right? So, and the next question that always becomes the hard part, most difficult for most people, is how can we find this? Or how can we relate these values, our givens, and our what we're trying to find? What's the process of getting there? Well, this one's not too bad because it's just basically a one-step problem. And we'll build to some more steps later on down the road. So what we're going to do is we're just going to take the total cost and divide that by the number of the eggs, right? And that'll give us a price, right? The cost per egg, okay? So for the 30 eggs, the cost per egg, the way we can get that is we take the $5.75 and we divide that by the 30 eggs. And so notice that would give us right around 19 cents, so 0.192 cents per egg, or 192 cents per egg. So in a similar manner, we can find what happens for the 12 eggs, that cost per egg. When we take the $2 and divide by 12, and notice that gives us around 16 cents per egg. So which one is the better option for us, or the better purchase? Better option is the dozen eggs in terms of price per egg. And the reason being is, well, it's cheaper in terms of it only costs us around 16 cents versus per egg versus the 30 eggs when we're buying that, even though that's on sale, it's 19 cents per egg. And this is one of the ways you can be tricked at a grocery store, right? You see more, you think, oh, it's a better buy. It's not always the case. A lot of times it is, but sometimes it's not. And so that's why we go through these comparisons, right? We try and match up the units. And it can happen for ounces, like if you're looking for ounces of a drink of some kind or things like that. There's all sorts of different ways to kind of cost compare when you're at a grocery store. Okay, so moving forward, let's try another one that happens pretty frequently, is this currency conversion. So due to the lack of Starbucks in Europe, Danny wishes to travel back to America from her European vacation a week early. If Danny has 600 US dollars available to purchase the ticket and the price of the ticket is 475 euros, then does Danny have enough money to purchase a ticket? So this is going to be the same song and dance in how we prepare, brainstorm, and go on and find our solution. Well, so for the preparation, what information do we have? Well, the first thing is the cost of the ticket, right? The cost of the ticket is 475 euros. So I guess you could say first thing from a location standpoint in the paragraphs is Danny has $600. Now there's one other piece of preparation. I'm making this more of a real world example. So what most people would do so you have some websites that would actually convert this for you, right? They do the conversion and everything's hunky-dory. The problem with that is just because you might look it up and it says, oh, this would be the currency exchange right now, given at this time. And by the way, currencies do fluctuate from time to time. But even though you might have that listed on there, that might not be what you can get when you're at a certain location. And what do I mean by that? Well, you might have a currency exchange that might not be as good or whatnot when you're trying to exchange that money. Trust me, because everyone's trying to make a dollar themselves. So let's say the currency that you can get while you're out there is for every US dollar, you can get 0.78 euros. Okay? And so from here, we can start to build and see what we can do. So what are we looking for? Well, we're looking for a comparison of the plane ticket cost and the amount of US dollars available. So now how can we compare these two values? We're going to have to convert one of the currencies. Whether we convert the euros to dollars or the dollars to euros, it doesn't matter. We can still compare either way. But just remember, we have to basically have enough money to cover that plane ticket cost. So just for convenience and how it would actually work if you're overseas, let's convert dollars, US dollars, to euros. So in that case, we start with our $600 and we want to cancel out dollars, so we put dollars down below, and then the euros must go on top of the fraction. So our dollars will cancel in time. So now we just need that conversion, and that is $1 for every 0.78 euros. We had that information from, say, we went to our currency exchange counter. And I know it's not in the problem. I would give you that information if I were to give you a problem, but I just want you to be aware of how we can work these. So now, what does that give us? Well, you can plug that in, and you end up getting 468 euros. Okay. So what does that mean? Well, Danny only has 468 euros and the ticket is 475 euros, so she does not have enough for that plane ticket. So what Danny can do is just extend her European vacation and enjoy that time there. So but there's no plane ticket home for that time period. Okay, so hopefully that makes sense on that one. And now we'll get into one that has multiple steps, so kind of build into something much larger and how do we compare and whatnot. So this race against time. We have Jackie running a 10-mile race against an opponent notorious for starting an extremely fast pace while slowing down towards the latter half of the race after building that big lead. So suppose Jackie's opponent begins the first 6 miles running at a speed of 10 miles per hour before slowing to 7 miles per hour for the last 4 miles. Meanwhile, Jackie begins the first 3 miles running at a speed of 6 miles per hour. What speed must Jackie run the last 7 miles of the race in order to finish at the same time as her opponent? Same as always, we're going to start by preparing what information do we have. We have the opponent running first 6 miles at 10 miles per hour, and then the last 4 miles at 7 miles per hour. Meanwhile, Jackie runs the first 3 miles at 6 miles per hour, and the last 7 miles at, well, we really don't know. And the reason we don't know is because when we go through this brainstorming process, well, what are we looking for? We're looking for the speed Jackie has to run those last 7 miles to finish in a tie, right? So now comes the tricky part. How do we relate these things? So how do we actually relate all these values? Well, we know that speed equals distance divided by time, and that's going to be important, but a better route would probably be we're looking for them to finish at the same time. So maybe we want to use, if you multiply time and then divide both sides by speed, you get time equals distance divided by speed. That's probably going to be the better one. And now what that allows us to do is we can find the amount of time it takes for both the opponent and Jackie to finish and set those equal to one another. So we'll begin with the opponent's time. So the distance is 6 miles for the first part, and then we got to divide that by the speed of those first 6 miles. Well, the speed is 10 miles per hour. And then the other leg, we'll add this together, is there's 4 more miles left, and we got to divide that by the speed, so the speed is 7. Now, just making this where it has a common denominator, that would be 42 over 70 plus 40 over 70, I believe. And we get 82 over 70 hours, right? Now, Jackie's time, we have a thing that we are looking for, so we're going to let x be the speed of the last 7 miles. Don't have to call it x. You can call it smiley face, Chewbacca, whatever you want. I'm just going to put it x for simplicity's sake. So in Jackie's first part, notice she runs 3 miles at 6 miles per hour. So you take the 3 for the distance, and you divide that by the speed. It comes from our equation for time. And then plus 7 divided by x, right? And the reason it's x is due to x being that missing thing we're looking for. So this can be reduced down to 1/2 plus 7 over x. And remember, this is also in hours, right? That's important. So now, how do we go about, how do we proceed from here? We just set the times equal and solve for x. That's it. So we get 82 over 70 as the opponent's time. So that should be equal to 1/2 plus 7 over x, which is Jackie's time. And so now we can subtract 1/2 from both sides. So you get 82 over 70 minus 1/2 equals 7 over x. And then that means just getting a common denominator, 82 over 70 minus 35 over 70 equals 7 over x. And so then moving forward from there, we get 47 over 70 equals 7 over x. Now what do? Well, we can cross multiply. And what do we mean by that? Well, basically you'll take the 47 and the x and you'll multiply together, and you'll take the 70 and the 7 and you'll multiply together. So you get 47x equals 7 times 70, which means x equals 490 divided by 47 when you divide that 47 from both sides. And so that's approximately 10.43 miles per hour if you just punch that into a calculator. So our solution to this is Jackie must run about 10.43 miles per hour for the last 7 miles in order to tie her opponent. Okay, so hopefully that gives you some insight into how to solve a problem where we have multiple steps involved. And if you have any questions on going through this problem solving, the prepare, brainstorming, and there might be a little bit more time consumed in trying to find those relationships and things like that. But don't get discouraged. Just keep on trying, plugging away. That's why it's called brainstorming. You just keep on working until you kind of get an answer and get to that solution. So let me know if you have any questions. Have a good one, folks.